Hi everyone, we're Virtual Leap Technologies. What we've been working on this semester is a gesture-based interface for 3D modeling programs, eventually looking to make a common scheme across all different 3D modeling programs so that you can do the same sort of gesture input and have a similar response in different programs. A little bit about our team. I'm Kyle Rector. I'm focusing in VPI. I'm graduating in May.
I'm David Silverberg. I'm also focusing in VPI, graduating in May.
I'm Joe Weslowski. I'm in VPI and also graduating in May.
And of course, Dr. Hartman, who is our faculty sponsor, but also out because of injury right now. So a little bit about where we've been working this semester. We've been working in the PLM lab, Kanoi 373. It's where we conducted our testing, and it's where we gave our go, no-go. It has all the software and equipment that we needed to do what we're doing. We've also received a lot of advice from grad students working in there. So our emerging technology that we're utilizing is the Leap Motion Detector. It's kind of like an Xbox Kinect, but a lot smaller, and it operates on a smaller scale. It has 2 cameras and 3 infrared sensors, and it gives you all kinds of spatial data that you can use for whatever program you're working with. It also can detect up to 10 digits simultaneously. So a little bit about our deliverable. We're going to be turning in code. It's all in C++. Our most recent version has 314 lines of code, and it utilizes 2 APIs, the one that comes with the device, the Leap Motion, and the Windows API. And the 3D modeling program we used for testing was NX 7.5. Here's a video of our initial product. It wasn't very responsive. This is our first attempt. You use 2 fingers to rotate. 1 finger moves the cursor, and your whole hand allows you to pan the part around the screen. So what we did for testing is we had 2 different treatments, and all the subjects had to take both on separate days. First, they used the keyboard and mouse to manipulate an object in the 3D modeling program, perform a set of tasks. And then on the second day, they did a similar set of tasks using the Leap Motion device. Some problems we encountered in testing was jittery input, and that was a problem with my code. Just couldn't interpret the data in time. Other problems we experienced was with the CAD package itself. NX is very finicky, and also the computer had some graphical limitations that made the part disappear at times. What we got from testing, we had 30 subjects take both treatments. Only one of the subjects was unfamiliar with the concepts of pan, zoom, and rotate. As you can see from the chart, most of our subjects had 3 or more years of experience with any 3D modeling program. Further from this, over half of our subjects had both experience with NX and CATIA. CATIA and Maya. But only a third had ever used NX, which might have something to do with the results because a lot of people had trouble picking NX up with either interface. Also, we found that those who had 2 years or fewer experience with any 3D modeling program actually picked the Leap up that interface more quickly. And we think that's because the muscle memory you get from using a 3D modeling program maybe wasn't as solidly ingrained in them. We also found out that those who had used keyboard and mouse in general less frequently performed more quickly. So on our most recent version, you use 2 fingers to manipulate the cursor. We had to change that from rotation because now we have a click function that utilizes 2 fingers. So as you'll see later, we actually changed the rotate to a different input, which should be right here. Like I said, we're using 2 fingers as part of a click functionality now, so now we have 4 fingers that allows you to rotate the part. And it also allows for a more natural transition into the next method of movement, which is panning, and that is still, as you'll see in a minute, 5 fingers. That has been the same through every iteration of our product. We did this because in NX, when you're going to pan the part, your cursor turns into a hand, and we thought, hey, that makes sense. So you use all 5 fingers to pan the part, and it's also kind of a natural way to push something around on screen. And of course, it wouldn't be complete without zooming functionality. We got our inspiration from this from smartphone and tablet interactions where you use pinch to zoom. It's not exactly using your fingers to pinch, but it's a very similar interaction, and we think that it just makes sense to use. On our most recent version of our product, like I mentioned earlier, we actually have clicking functionality. So here you can see simple geometry creation in the CAD program utilizing the clicking. It's not quite as accurate as a mouse. As you can see, I missed several times there when trying to select the line, but we're working on making it more accurate. But as I said, you can create geometry, and with the click actually utilize pretty much every feature of the 3D modeling program. Also, as I mentioned earlier, we're looking to make the same gesture-based interface across several 3D modeling programs. So here is our version that works with Maya. The zooming works the same with 2 hands moving forward and in and out. Rotating is 4 fingers, and panning is 5, and clicking is also the same. And we didn't just stop at Maya. We actually made more versions for 3ds Max and CATIA to try to encompass all of the different types of modeling we could think of. CATIA especially because it was very popular among our subjects. And we don't have videos for it yet, but we do have the code. We'll be looking to make videos before the final presentation. Some things we'd like to do with our product is actually include some of the gestures that the Leap inherently recognizes, such as a screen tap. It's kind of where you just push your finger forward. And we would like to make that the click. And then use our current click action to actually cycle between options. So you could click to go to pan, and then rotate, and then back to cursor. And we think that would eliminate a lot of the jumping around. Just to conclude, our final presentation is next week on Thursday, April 18th in Stewart 214 between 2 and 3 p.m. And we hope to see you all there. And if you'd like any more updates on our product or any videos, you can go to our website at virtualleaptech.com. Thanks.
We'll reserve comments to Lean's